Hello students, from the chapters alcohol, phenol and ethers, let's continue the topic preparation of phenol from cumin. Cumin is also known as isopropyl benzene. It is the commercial method for the preparation of phenol. It is also called as auto-oxidation, in which cumin is oxidized in presence of cobalt naphthalate as a catalyst. The reaction occurs in alkaline medium at 413 Kelvin. When cumin oxidized, it forms cumin hydroperoxide, means two oxygen atom attached with carbon atom. This cumin hydroperoxide heating with dilute sulfuric acid, means dilute H2SO4, and decomposed to give phenol and acetone. Cumin hydroperoxide heating with dilute H2SO4 and decomposes to give phenol and acetone. Phenol means aromatic ring contain hydroxy group, and the remaining part is acetone, means CH3 C double bond O CH3. The another method for the preparation of phenol is from aniline. This method is also known as diazotization. In this method, aniline is treated with nitrous acid. It gives benzene diazonium salt. Here the name of the salt is benzene diazonium chloride. Means nitrous acid react with aniline and it form the main product benzene diazonium chloride, and water molecule will be removed. See here in the reactant, total hydrogen atoms are 2, 3 and 4. 4 hydrogen atoms are there and 2 oxygen atoms are there. So these 4 hydrogen atoms combine with 2 oxygen atom and it form water molecule. The remaining parts of the reactant react together and form benzene diazonium chloride. This benzene diazonium chloride, the formula of, as you have seen student, the benzene diazonium chloride aromatic ring contain N triple bond NCl, where nitrogen carries positive charge and chlorine carries negative charge. This benzene diazonium chloride is hydrolyzed, means the aqueous solution of benzene diazonium chloride is hydrolyzed to give phenol. Aqueous means mixed with water, so aqueous solution of benzene diazonium chloride is hydrolyzed with dilute sulfuric acid. It gives phenol. So these are the two methods for the preparation of phenol. One is from cumin and another is from aniline. The next part of this chapter is ethers. As all of you know, ethers are the compound which contain oxygen atom bonded to two alkyl groups or two aryl groups, or one alkyl and one aryl groups. Students, ethers are the compounds which contain an oxygen atoms, and this oxygen atom is bonded to either two alkyl groups or two aryl groups, or one alkyl or one aryl groups. Actually, ethers are organic oxide. Ethers are considered as anhydride of alcohols. See the general formula ROR. Oxygen atom is bonded with two alkyl group. Next general formula ROAR means oxygen atom is attached or bonded with one alkyl or one aryl group. Next is AROAR means oxygen atom is attached or bonded with two aryl group. As all of you know, aryl group is nothing but a aromatic ring. So here you can see the ethers are a compound which contain oxygen atom bonded with two alkyl group, one alkyl, one aryl group, or two aryl group. Now the classification of ethers. In classification of ether, there are two types of ether. One is symmetrical ethers, and these symmetrical ethers are also known as simple ethers. Symmetrical ethers are also known as simple ether. In this ether, both the alkyl or aryl group attached to oxygen atoms are same. See here, oxygen atom contain two methyl group, means both the alkyl groups are same. In next example, both the aryl groups are same. So symmetrical ether means in which both the alkyl or aryl groups attached to oxygen atoms are same. The next type of ether is unsymmetrical ether, which is also known as mixed ether. In mixed ether, two alkyl or aryl group attached to oxygen atoms are different. See here in the example, ethyl methyl ether. One side of oxygen attached ethyl group and another side attached methyl group. Same here in the next example, one side of oxygen attached phenyl group and another side is attached ethyl group. So it is classification of ether, and ethers are classified into two groups. One is symmetrical ether or simple ether, another is unsymmetrical or mixed ether. Next topic is nomenclature of ether. As all of you know, students, the nomenclature of any organic compound there are two methods for the nomenclature of the organic compound. One is common name and another is IUPAC name. First we take common name. In common name, simple ether are named as dialkyl ether or diaryl ether. Students, remember it. Simple ethers in common name are named as dialkyl ethers. For example, see the structure formula CH3OCH3. So dimethyl ether or diaryl ether. The common name of mixed ether is obtained by entering the name of alkyl or aryl group as separate words in alphabetically order, followed by the word ether. In mixed ether, named as alkyl or aryl group as separate words in alphabetically order, followed by the word ether. See in this example, CH3O, CH2, CH3. So alphabetically ethyl, methyl, and at the end ether. Third example, it is also mixed ether. So it is one side methyl group is there and another side propyl group is there, but it is not isopropyl. It is a longest chain, so simple chain, normal chain, so it is N-propyl. N-propyl. So alphabetically the name of the ether is methyl N-propyl ether. Now next, in one side of oxygen atom methyl group is there and another side is phenyl group is there. So it is very common ether. You can named as anisole or you can named as methyl phenyl ether. Methyl phenyl ether. See next, also it is mixed ether. One side of oxygen is phenyl and another side of oxygen is N-propyl. So the name of the compound is phenyl N-propyl ether. The next compound having no common name. See here, first structure dimethyl ether, second ethyl methyl ether, third methyl N-propyl ether, fourth methyl phenyl ether, next phenyl N-propyl ether. Now take IUPAC name of ether. For the IUPAC name of ether, actually ethers are considered as derivative of hydrocarbons in which hydrogen atoms is replaced by OR or OAR group. OR means alkoxy group or OAR means aryl oxy group. In mixed ether, the alkyl group containing larger carbon chain is considered as parent chain, and you can name the IUPAC name for ether as alkoxy alkane. See here, alkoxy alkane. The first structure is both the alkyl groups are same, so it is methoxy methane. In second structure, it is one methoxy ethane. On one side methyl group is attached and on another side ethyl group is attached, so it is methoxy ethane. Next one, as there are more than 2 carbon on one side of the oxygen atom, so numbered as 1, 2, 3. So it is 1 methoxy propane. See student, 1, 2, 3. So it is 1 methoxy propane. Next one is methoxy benzene. Methoxy benzene. Next one is 1, 2, 3. So 1 propoxy benzene. 1-propoxybenzene. Next one is 1, 2, 3 and 4. 1, 2, 3 and 4. So this box is contain 4 carbon atom and name of this box is cyclobutane. In this cyclobutane, first number of carbon contain 2 methyl group. Second number of carbon contain methoxy group. So name of the compound is 2-methoxy 1,1-dimethyl cyclobutane. This box is known as cyclobutane. So it is 2-methoxy 1,1-dimethyl cyclobutane. The next topic from ether is preparation of ether. The first method for the preparation of ether is dehydration of alcohol. In dehydration of alcohol, here we are using hydrating agent sulfuric acid or phosphoric acid, either concentrated H2SO4 or H3PO4. So in this method, when alcohol is heated with dehydrating agent like concentrated H2SO4 or H3PO4, two products are possible, either ether or alkene. Either ether or alkene. It can depend upon the temperature. For example, dehydration of ethanol by sulfuric acid gives ether at 413 Kelvin, but at 443 Kelvin it gives ethene. So student, when alcohol is heated with dehydrating agent like concentrated H2SO4 or H3PO4, two products, either ether or an alkene, can form depending upon the temperature. For example, dehydration of ethanol by H2SO4 give ether, but the temperature is 413 Kelvin, while ethene is formed at 443 Kelvin. See here, ethanol is there, double quantity of ethanol is there. As you have seen, 2 ethyl groups are there. So 2C2H5, C2H5, see in the product 2C2H5. 2 oxygen atoms are there, from which one oxygen atom is attached with 2 ethyl group and one oxygen atom is attached with 2 hydrogen atoms and form water. It is the byproduct of the reaction. I am explaining again. 2 ethyl groups are there, means whole the ethanol are in the double quantity. From these 2 ethyl groups and 2 oxygen atom and 2 hydrogen atom This 2 ethyl group is attached with 1 oxygen atom and 2 hydrogen atoms are again attached with 1 oxygen atom. So hydrogen atom react with oxygen atom, form water molecule, which is the byproduct of the reaction, and 2 ethyl group attached with oxygen atom form ether. It is nothing but a ethoxyethane. It is the simple ether which is formed at 413 Kelvin, which is formed as 413 Kelvin. Now in the next reaction again ethanol is there, but it is in a single quantity and the temperature is 443 Kelvin. Again byproduct is water molecule. 1 hydrogen atom from ethyl group, 1 hydrogen atom is there, react with oxygen atom, form water molecule as a byproduct, and remaining compound is C2H4 means CH2 double bond CH2 means it is ethene. So only the temperature is different. So one first reaction form ether and second reaction form ethene. Symmetrical ethers can be obtained from primary alcohol by this method only. Means primary alcohols form symmetrical ethers. Primary alcohols form symmetrical ethers. In another condition, when we are using higher temperature or secondary or tertiary alcohol, the alkene is the major product. So always remember student, primary alcohol can form symmetrical ether by this method, or at high temperature secondary or tertiary alcohols form alkene as a major product. The next topic is Williamson synthesis for the preparation of ether, which we will continue in the next lecture. I hope you understand all this topic. Thank you so much.